This is the e-learning lesson for Friday, December 10th over section 5.1, Properties of Exponents. This is our first day on this section, and it is a review of the properties of exponents you learned back in Algebra 1. So at the top of this handout, which can be downloaded from Canvas, either as a blank page or as a completed notes page, you can see at the top the examples for the properties of exponents. So we're going to start with the first property, the property of powers. And if you take a look at the rule, when you multiply like bases, what you do with the exponents is you add them. So in my example, I have x to the 9th times x to the negative 5th. And when I add 9 and negative 5, I get x to the 4th. This can also be used with bases that are numeric. 3 to the 2nd times 3 to the 5th, you add the 2 and the 5 and get 3 to the 7th. So that's when you multiply like bases. The second property is the power of a power property. In this property, you have a base raised to an exponent, which is raised to another exponent, and you see parentheses and an exponent raised to an exponent. Well, in that case, you multiply the exponents. So in my example, x squared raised to the third power, we multiply the 2 times the 3 and get x to the 6th. Now, I did expand that expression. X squared raised to the third literally means 3 factors of the base x squared, which I've expanded here, and then using property 1, you would add 2 plus 2 plus 2, and again, that's just trying to confirm that is why you multiply the exponents when you have a base raised to a power, which is then raised to another power, called a power to a power. Rule 3, a power of a product property. This is where you have a quantity in parentheses raised to a power, so a times b in parentheses raised to the m power would be equivalent to a to the m and b to the m. You're really multiplying the exponent of 1 that both a and b are raised to implied in parentheses times m, and that's why you get a to the m and b to the m. So in my example, you can see here 2x to the 4th y. The 2 and the y are really raised to the first power. And then that quantity, 2x to the 4th y, is really raised to the third power. So for each factor of that quantity, you're going to raise it to the third power or multiply the exponent by 3. So for the base 2, 1 times 3 gives us 2 to the third. For the base x, 4 times 3 gives us x to the 12th. And for the base y, 1 times 3 gives us y to the third. Of course, we can simplify 2 to the third to get 8, 2 times 2 times 2. So our final answer becomes 8x to the 12th, y to the third. That's the power of a product property. Then we have the negative exponent property. When you have a base raised to a negative exponent, we can rewrite it as 1 over that base raised to a positive power. So I've given a problem. I have x to the negative 9th times x to the 5th, and when I multiply those quantities, because we have like bases, we add the exponents first. That gives us x to the negative 4th. And because the result has a negative exponent, and as a rule, we don't want to leave terms with negative exponents, we rewrite that as 1 over x to the positive 4th. Then the zero exponent property. Anytime you have a base raised to the 0 power, that is always going to result in having 1. So 253 raised to the 0 power would be 1. X to the 0 power would be 1. I will show in class, well, I can see right here on my examples right here, when you divide x to the 6 by x to the 6, the next property, the quotient of a power property, says when you divide like bases, you actually subtract the exponents. And so you can see in my example to the left, x to the 11th divided by x to the 4th, because they're like bases, we would subtract 11 minus 4 and get x to the 7th. Well, when you take x to the 6th over x to the 6th, when you divide those like bases and subtract the exponents, 6 minus 6 gives us x to the 0, which confirms why anything raised to the 0 power is really 1. That was the point of that problem. When you know the result of x to the 6th over x to the 6th, because those terms are the same, have to cancel and reduce to 1, and you also know you subtract the exponents, which gives you x to the 0, that confirms why any base raised to the 0 power would be 1. Then we have the power of a quotient property, and when you have a base that is a fraction raised to a power, you actually raise both the numerator of that base to the power as well as the denominator of that base to the power. So in my example, the fraction 2/3 raised to the second, I rewrote as the numerator 2 raised to the second over the denominator 3 raised to the second, and then I simplified. 2 squared is 4 and 3 squared is 9. What happens if that exponent is negative? Well, there's a great property. It's the reciprocal property of a quotient. If you take a base and you take its reciprocal, if the exponent in the original problem was negative, when you take the reciprocal of that base, the exponent becomes positive, which of course then we can further simplify by using the quotient property. So I'm showing you over here 2/3 raised to the negative second is equivalent to the reciprocal 3/2 raised to the positive second, and then you would square both the numerator and denominator, and that's how you get 9/4. I showed you here the other way of getting it, which is much more complicated. You see, you could use the negative exponent property and rewrite it as 1/2 to the second, and then you could simplify that by taking 1/4/9, which when you divide 1 by 4/9, you get 1 times the reciprocal 9/4 or 9/4. And then I did it here with a negative exponent to show you the same thing. 2/3 raised to the negative second becomes, this is an alternative way, you can take the base 2 and raise it to the negative second, and the base 3 and raise it to the negative second, and then like my arrows are showing here, you can actually take the reciprocal, and that gives you 3 to the positive 2 and 2 to the positive 2, but they're relocated. 2 had a negative exponent in the numerator. It has a positive exponent in the denominator. And 3 had a negative exponent in the denominator, so now it has a positive exponent in the numerator. So that becomes 9/4. So those are your properties of exponents, all of which you should have seen before in Algebra 1. It's just reviewing them, and these are good examples to fall back to. So the bottom half shows some problems that I would have had you do in class independently, and you're going to want to look at each of these to make sure you understand how we arrived at the answer and that you agree. So the first several are pretty easy. For instance, number 1, when you multiply like bases, you just add your exponents. The last c has an implied exponent of 1 that you don't want to overlook, but the end result is you get c to the 8th. Then in 2, when you multiply like bases and add the exponents, that produces x to the negative third. But of course, we don't want to leave our answer with a negative exponent, so we rewrite it using the negative exponent property as 1 over x cubed. In 3, it's a power to a power, so you just multiply the exponents. 4 times 2 gives you g to the 8th. And 4 is an extension of that because the term 3u squared w is being raised to the third power. The implied exponent on both the 3 and the w is a 1. And so for each factor of that term, when you raise it to the third power, you multiply those exponents. So it literally would become 3 to the third, u to the 6th, w to the third. And of course, 3 to the third is 27, so that's why you see for the answer 27 u to the 6th, w to the third. Number 5, when you simplify that, the negative 1 as the coefficient is being raised to the third power. 3 factors of negative 1 would be negative. And then for the base r, you would multiply the 7 times the 3, and that gives us 21. Number 6, dividing like bases, you subtract your exponents. So 15 minus 12 gives you s to the third. Number 7, when you divide, we have to divide the coefficients. So 24 divided by 3 is 8. And for like bases, we subtract our exponents. Remember, when there's no exponent, that's implied to be 1. So we have 1 minus 3, which gives us w to the negative second. And for the factor z, 7 minus 5 gives us z to the second. And of course, we can't allow our answer to have a negative exponent, so any factor that has a negative power gets rewritten. So our final answer here becomes 8z squared over w squared. Number 8, before you can multiply these two quantities, because 2x is being raised to a power of 2, and the quantity 4x cubed y is being raised to a power of 2, you actually need to do those powers first with what's in parentheses. So when you square 2x, that would be 4x squared. Oops. That would be 4x squared. And then when you cube 4x to the third y, the 4 squared is the 16. And then for x, when you multiply those bases, you get x to the 6th, and for the y, you get y to the 2nd. Then you can multiply, and when you multiply the coefficients. 4 times 16 is 64, and then for like bases, you add the exponents. So x squared times x to the 6th gives us x to the 8th. There are no other factors of y, so we just carry that over when we multiply. So our answer there is 64x to the 8th, y to the 2nd. Number 9, you got to simplify the numerator first. Take a look. When you square negative 10, that's 100. For a, you would multiply the power of 1 by the exponent of 2. That gives you a squared. For b, you multiply the exponent of 4 by 2. That gives you b to the 8th. And then the denominator, of course, is 25, a to the negative 4th, b to the 11th. So when you go to divide, you divide the coefficient. 100 divided by 25 is 4. And then for like bases, you actually subtract those exponents. So you got to be careful, because for the base a, you're actually taking 2 minus a negative 4, and that becomes 2 plus 4, or 6. Then for the base b, you would be taking 8 minus 11, which is negative 3, which we, of course, have to deal with. We need to express our answer with no negative exponents. So we're going to leave 4a to the 6th in the numerator, but the b to the 3rd we'll take to the denominator with a positive 3 as its exponent. Number 10, The reciprocal property is your best option here. Since we have the fraction 3/5 raised to the negative third, I rewrote it as the reciprocal 5/3 raised to the third, and that gave me 125 over 27. I cubed both the numerator and denominator. The last two I'm going to let you take a look at to make sure you understand. So take a look at those. 12 is the one that's a little trickier. You do have to do the power and then simplify the numerator as well as the denominator. Once I did that, I did reduce the negative 36 and the negative 9. And that, I multiplied here. I reduced and then I multiplied. So negative 9 goes into negative 36 4 times, and then I took 4 times 4 to get the 16. And then the rest is pretty straightforward. Just remember, when you divide with exponents, you subtract. But when you subtract, you got to be careful. For the base m, 4 minus 1 is 3. But for the base n, we have negative 2 minus a negative 4. Negative 2 plus 4 becomes m squared. So you just want to make sure you're careful there. All right, your assignment can be found in Canvas. It is, I believe, page 307 and 8, 1 to 4 all, 16 to 23 all, 42, 43, 46, and 50. Take a look in Canvas to see that assignment. Have a great day.